So for our practice with Python, I'd like you to first import module regular expressions. Then you will need to have this scraping.txt text that you have in the module for week 4. And this is what it looked like actually. It's just a small text with dates information and some meeting notes. So what is our task for today? We are asked to find all dates in this text. So first of all, we need to explore a bit, just to scan maybe head or tail of our data to see what it looked like first. And if you're looking for dates, so we have dates written in this form. So we have characters, numbers, we have punctuation, and we have year information. So we need to explore our data by scanning and define what format are possibly out there. We may not find all of them, consider if our data is very large, but we can have at least some understanding. Then we're going to identify pattern. And what we found so far, we have a month, then followed by space. Then we have 2-digit pattern for date. We have comma, we have space, and we have year as a 4-digit pattern. And if you look at most of them, even they're followed by some other characters, but we can't identify clearly, we still have 4-digit numbers for our year pattern. So now step 4 will be to build our pattern, and then finally we can test. And if it's not really pulling everything we need, then we'll revise our pattern. So I suggest you organize your workspace with the code folder where you have your regular expression notebook, with the data folder where you place your input file, and figures. We don't need figures this time, but you can always create folders like that, additional folders. So first we need to actually open our text file. And if you organize it this way, you can always specify where it's located and what file to import. Now we need to match our pattern. So we have this idea that we identify as a potential pattern, and let's build it together. So we have month as characters, not just one, but several characters. So we don't know how many, but it have to be at least more than one. And it can be capital, it can be small letters. So we need to pull all of them from A to Z capital and A to Z small letters with plus. We know there's a space between them. It may be more than one, but for now it looks like there's one. So we put in that S for space. Then we need 2-digit number for days. And instead of just specifying how many, let's simply put 2 classes with 1 item in each. We have comma, we place comma as there's just simple character, then another space. And now we have 4 digits, and now let's save some time of typing. We specify we need 4, exactly 4 of those numbers. All right, so we're going to open our file, and we will, in this case, since it's a text file, it's not a data frame, we'll read each line in our file. So first we import it. We're reading files, we're saving it in the content object. Now we're going to go through each line in our content, and we will find those patterns. Here's our pattern. Here's the function that we use, find all. This is the function module that allows us to use regular expressions, and line is the name of our content iteration of our content per line. So our condition would be, if our date is found, we're going to print it. So if length of x in this case is going to be more than, it will not be equal to 0, means it's found, then we're going to print it. Let's see what it looked like. And it printed 4 patterns. And I just know it's correct. It doesn't have more than that, so our test is complete. We don't have to revise it. All right, let's look at compile version. If you notice, before we just used find all. Compile can be a bit more efficient because we can save this pattern and reutilize it later on. And to compile, to use this version, we would use compile function where we input a raw string notation. So the way it's written is you precede your pattern with R and put it in, enclose it in quotes. So for instance, if I compile this pattern, that means I'm looking for any numerics of 1 or more. For instance, given this string and given the pattern that I just compiled looking for any numeric of 1 or more, my result will be, I will match this pattern over string, which is given here, and I will print results in group, meaning just print, give me everything. And as a result will be 007. Try it out yourself. All right, let's rewrite our first code since we did not use compile. So let's create a pattern and place our given pattern that we utilized before through this compile version. So I suggest, instead of using line by line version that structure that we used before, let's clean it a little bit. Let's combine all the line in together. Let's remove any trailing spaces. Remember those spaces that can occur before and after, like extra spaces, and also remove new lines. We don't really need to preserve this structure. So we'll do it by just joining all the lines with just a space. We'll be stripping our lines, and we also will be stripping our new lines. All right, for each line in our content, in our text data. So this is what it's going to be, look more compact, and we can now work with it. And now we can find all patterns. Remember, the patterns are as object right here, and we apply this pattern on our string, which is just this chunk of text, and it's printed, of course, in this case per line, since we're not dealing with our per line version. And you can see we have 4 of those correctly printed. We can also use our pattern in splitting, and splitting would be useful if you have if you already know what separator to use. For instance, you know it has to be a comma or space, then you can split your given string, not necessarily a character, it could be numeric, but split them by certain separator. And if you look in this case, we can compile our pattern also, and we can say let's split by any space, could be 1 or more, also split by any non numeric or alphanumeric characters. So it means whether it's punctuation, we don't need that, let's split by that. And this is our OR condition. And as a result, we have some sort of tokenization of our input. So in summary, we can use matching, searching, find all function that we use, of course, splitting, subbing, and compiling.